Dijkstra's algorithm is used to find the shortest path from a source node to all the other nodes in the graph. It is based on this idea to keep exploring new paths that are shorter. Let's say we start with the source node 0 and we want to find shortest paths to all the other nodes in the graph from node 0. Here is the pseudocode for Dijkstra's algorithm. We first initialize the distances to all the nodes as infinity and add 0, 0 to the priority queue. The first element is the distance and the second element is the node itself. Next we execute this while loop. We pop the only element in the priority queue right now, which is node 0, and we see that distance to node 0 is greater than the distance we popped just now, so we update the distance to node 0 to 0 and we check its neighbors, which are 3 and 1. So the distance to node 1 is greater than distance to node 0, which is 0, plus cost of the edge 0, 1 is 5. So we add node 1 to priority queue at distance equal to 6 and node 1. We repeat the same for node 3. The distance to node 3 is greater than distance to node 0 plus cost of the edge 0, 3. We add node 3 to priority queue at distance 2 and node 3. Next we pop the closest element from the priority queue, which is node 3 at distance 2. We check the distance for node 3. Right now it's at infinity, so we update it to distance 2. Next we explore its neighbors, which is node 1, and the distance to node 1 is greater than distance to node 3, which is 2, plus cost of the edge 3, 1, which is 2. So we add node 1 to priority queue again at distance 4 and node 1. Next we pop the closest node from the priority queue, which is node 1 at distance 4. Right now the distance to node 1 is infinity, we update it to 4. Next we explore its neighbors, which are 4 and 2. Distance to node 2 is greater than distance to node 1, which is 4, plus cost of the edge 1, 2 is 5. So we add node 2 to priority queue at distance equal to 9 and node 2. We repeat the same for node 4, where the distance to node 4 is greater than distance to node 1, which is 4, plus cost of the edge 1, 4 is 1. So we add node 4 to priority queue at distance 5. Next we pop the closest node from the priority queue, which is node 4 at distance 5. We see that distance to node 4 is infinity right now, so we update it to 5. And we check its neighbor 2. Distance to node 2 is greater than distance to node 4, which is 5, and cost of the edge 4, 2. So we add node 2 again to the priority queue at distance equal to 6, node 2. We pop the closest node again from the priority queue. There are 2 nodes at distance 6. We pop any one of them. Let's say we pop node 1. We see that the distance to node 1 is 4, which is already shorter than the distance 6. So we do not explore this node now. So we do not check its neighbors. Next we pop a node again from priority queue, which is node 2 at distance 6. Node 2 is at distance infinity, so we update the distance to 6. Node 2 do not have any neighbors, so we continue with popping node from priority queue. We only have one node left, which is node 2 at distance 9. We pop it. Distance to node 2 we have right now is 6, which is shorter than the distance 9, so we continue. There are no more nodes left in the priority queue. We stop the algorithm here. So the shortest distance from node 0 to node 1 is 4, node 2 is 6, node 3 is 2, and node 4 is 5. If you found this video to be helpful, please support by liking the video and subscribing to the channel, and I will see you in the next video. Thank you.